G'day, Chris here and welcome back to ClickSpring. In this video I make the cutting tool to form this vintage style rope knurl. There are quite a few parts on both the current clock build as well as some future tools that I'd like to embellish with a rope knurl pattern. It provides a good functional grip and it instantly adds a classic look to the part. The rope pattern is formed by a knurling wheel that looks like this, that has a number of teeth around its perimeter. Now to form those teeth, I'm going to use an additional cutter that looks like this. Each tooth on this cutter has a 90-degree V profile, and there are 4 teeth milled around a central axis. There's relief at the back of each tooth, and the cutting rake angle will be generated by milling past the tool centre line. I'll be using some of this EN8 steel to make both the cutter and the knurl. And although my clamping set has some perfectly good diamond knurled lifting screws, I need a first test subject, so they'll be getting an upgrade. I bonded these in place with Loctite 603, so gentle heat breaks that bond and all pieces are ready to be reused. So let's get started. The first step was to make that double-angled cutter, so I loaded a fresh piece of steel into the lathe and then formed the basic profile. The profile features of the cutter are quite small and also very close together, so I'm going to form them using this universal cutter. Providing I don't push it too hard, it'll cut well both left and right handed, letting me make all of the required cuts with the one tool. Okay, with the profile complete, the next step is to form those cutting teeth. The work needs to be accurately indexed for 4 teeth, so I set it up on the mill, held in the dividing head. After finding the edge of the work, I positioned this end mill the correct distance past the centre line and then set about milling the gaps between the teeth. And for this part of the job, I'm using the simple indexing plate of the dividing head that's just behind the chuck. So that's the bulk of the waste stock removed and it's starting to look a bit like a cutter. Although at this point it does still need a bit of tidying up before it can be put to use. And I'm going to take care of that using this fine cut file and the slipstone. For the cutter to work correctly, the back side of each tooth needs to be relieved. So I'll be removing this little corner of metal here on each tooth and shaping it to blend with the back surface. The cutting edges also need these burrs removed from the last milling operation. So the geometry of the cutter is now complete. The steel just needs to be hardened and then tempered. And I tend to use a boric acid coating as well as soft iron wire to minimise heat scale when I heat treat. But I thought it might be worthwhile showing what happens to the steel if nothing is done to protect it while it's heated. So I've wrapped the working end of the cutter as usual, but I've left the chucking end uncoated and exposed to the torch flame. With nothing to stop the oxidation, the unprotected end has formed a thick black scale, while the protected end is mostly free from scale and looking quite bright. Off camera, I brightened up the surface of the tool with some emery paper so that I could monitor the colour change while tempering. A quick touch on the cutting faces with a fine oilstone, and that's the double angled cutter complete. Now you'll have noticed that the knurled teeth are cut on an angle to the body of the knurl, which means that the knurl blanks need to somehow be securely presented at an angle to the cutter. I could have simply cut them while they were still attached to the parent stock, but I figured since I was making a few of them, a dedicated holder would be a better way to go, and I can keep it for when I make more in the future. So I made this arbor to hold them on the mill. It's just a short spigot sized to be a close fit with the knurl blank, with a thread running down the centre. The arbor can be held in the collet chuck on the dividing head, and a socket head cap screw and washer are enough to hold the blank in place. Okay, now for the blanks themselves. And they're a reasonably straightforward piece of turning, although I did take care to drill and ream them so that they'd be a good fit on the tool that will hold them when they're in service. So that's 5 blanks ready to go. They just need a quick deburr and they're ready to fit on the milling arbor. Back onto the mill, the work was again secured in the dividing head and then tilted to an angle of 30 degrees. The cutter was carefully positioned against the work to make sure it was centred on the blank, and then the teeth were cut into the knurl. For this particular knurl, I indexed for 40 teeth, which was simply one turn of the hand wheel on the dividing head for each cut. Now the quality of the cut was a little rougher than I would have liked, so I gave it another pass without changing the depth, and that seemed to clean it up. With that first one complete, I used a few different angles as well as index counts to make the full set of 5 knurls, which will give me a good range of different rope knurl patterns. Each of those knurls was quench hardened and then tempered. And that's a set of rope knurls complete and ready for use. So let's give them a run. I've selected one of the knurls to form the pattern for my test pieces, and I've also made a few of the extra tools I need to complete the job. This bump style knurling tool as well as this form tool. Click on the links if you'd like to see the videos showing how these tools were made. Bump style knurling tools generate an enormous side force on the work, so tailstock support definitely helps. And even with this support, the work still deflects quite a lot as the pattern is formed. The form tool is plunged into the side of the work and the profile of the thumb wheel is formed with a single cut. The knurling tool holder is mounted onto the tool post and then slowly pushed into the side of the work. Now, I didn't make any effort to calculate the correct diameter to avoid double tracking. In fact, I was surprised to find that it wasn't really necessary. In no time at all, the knurl cut its way down to a diameter that worked and the pattern started to jump out. Within a few minutes, the pattern was cut to full depth and a light touch with some emery paper was enough to tidy up the surface finish. To complete the thumb wheel, I drilled and tapped the centre hole. After parting off, I used the threaded rod to hold it the other way around in the chuck and then turned the dome shape using a handheld graver. I'm really pleased with the way these test pieces have turned out, so you can expect to see more of this rope knurling in future ClickSpring videos. Thanks for watching. I'll see you later. If you enjoyed this video, then here's 2 more that I think you'll like. And if you're new to ClickSpring, thanks for dropping by. I post regular home machine shop project videos, so be sure to hit that subscribe button. And finally, if you'd like to help with the creation of these videos, then have a look at the ClickSpring Patreon page. Thanks again for watching. I'll catch you on the next video.